But today we're going to focus on acids only and a real particular attribute of acids, how to name them. So we're not looking at characteristics or pH or any of that. It's just if I give you an acid, which is a formula that starts with, oh, wake up. Acids are formulas that start with what element? H, hydrogen. Then how do you name him? Or if I give you the name of one, if I say hydrofluoric acid, how do you write his formula? And there's a very specific set of rules to do so. If you look on the back of your cheat sheet, I'm going to be in the very bottom section called acid nomenclature. And you'll see that these rules here are printed there for you. If you're watching the video, you need a polyatomic list in front of you. So pause and go get one of these. Naming acids just takes practice, so we're just going to dive in. So make sure you've got plenty of room to write what I write as I show you how we use these rules. Is that an acid? Yes. How do we know it's an acid? Starts with H. Don't just say H. All right. Having H isn't enough. It starts with H. So my question is, what do we call him? Once you realize it's an acid, what you're going to do is ignore the H. We no longer need the H for our purposes of naming. What we're going to focus on is that guy there and how we say him. Cl. How do we say Cl when he's in a compound? Chloride. Chloride. Remember, and if you've never gotten this, listen to this sentence. If it's just an element on the periodic table, like chlorine, then it ends in ide. The IDE is an element on the periodic table. So what we just said is he's pronounced chloride. Here's what you do. You take a look at the way you said that word, and it will end in a certain suffix. And you find that suffix here. Do you see I? Up top. And what we're going to do is get rid of the "ide" and put the root of the word, the leftovers, into the appropriate blank. So I don't want the "ide" anymore. I just want the chlor. I'm going to take the chlor. Do you see the chlor? And I'm going to put him into the blank that matches the right suffix. So this one becomes hydrochloric. Do you see it? And then what special word do you think we use for acids? Acid. HCl is hydrochloric acid. All right, that wasn't a part of the answer. That's just your intermediate brain step. Is he an acid? Yes, because he starts with hydrogen. Make sure you only apply these naming rules to acids. I'm going to cover up the H. ClO2. Find him. Find his name. ClO2. What is it? It's chloride. This is how you say the non-H part of that compound. I want to focus on the ite. Find him. Do you see ite? Now remember, we don't want the ite anymore. We want the rest of it. In this case, it's chlor again. I'm going to take the chlor and put it into the ite blank. What will it become? Chlorus. Chlorus what? Fluorescence. HClO2 is chlorous acid. I know it's an acid because it starts with H. I cover up the H and I'm left with SO4. What is the name of SO4? Sulfate. All right. What suffix is on that word? 8. All right. There's 8. It says that I want to put everything that's not 8 into that blank, making it, a lot of y'all would say sulfic, and that's fine. If you put sulfic, I won't count it wrong. But just because of English stuff, this isn't chemistry stuff, this is just English. We don't call it sulfic, we call it, anybody? Sulfuric. But if you put sulfic, whatever, at least I can see that you're doing the rules right. It's sulfuric acid. Real quick, look back at our 3 examples. Just kind of pull your head back so you can see all 3 of our first examples. How many of them start with H? All of them. They all start with H, right? How many of their names start with hydro? Only one of them. Look here. The biggest mistake that you make is you fall into this trap where, since they all start with H, your brain always wants to pick the answer that starts with hydro. That's just not the case. Most of the time, their names does not start with hydro. They always have hydrogen at the beginning, but they do not always have hydro at the beginning of their name. So don't be that student. The only time hydro gets to be a part of their name is if the original starting suffix was "ide," which will be true 1/3 of the time. You try a couple, and then we have to name them the other direction. Name those. Call me over if I can help you. On my first example, I know it's an acid because it starts with H. I ignore the H. CO3 is carbonate on your polyatomic list. Carbonate is going to activate my middle rule because of the 8. So I don't need the 8 anymore. I just need the carbon to go into that blank, and it will become carbonic acid. On my second example, I know it's an acid because it starts with H. I ignore the H, and all I see is N. Nitrogen is just an element on the periodic table, so I'm going to pronounce him nitride. The ide is going to activate, but I don't want that to be a part of the answer. It's NITR that's left over, so I'll put that in that blank. And it becomes hydronitric acid. Anybody get different answers? Now, if you look above my head at your assignments, you'll see that there's 2 different acid namings online. It's because they're separated by the different directions. So, you know how to go from formula to name. You need to be able to go from name to formula. Write this down. Now we need to orchestrate the formula from the name. Nitric acid. What element must that start with? H. Right away, we know it's going to start with an H. All right? The word acid tells me H. Now it's the word nitric that we need to look at, though. If you look closely at this word, the first word in an acid, you'll always be able to find one of these scenarios. It's either going to have hydro at the beginning and ic at the end, it'll have just ic at the end, or it'll have us at the end. Which one does this word have? 1, 2, or 3? Yeah, it just ends in ic. So all you've got to do is go in reverse. All right? Before it ended, let's do it like this. Before this word ended in ic, what did it end in? It ended in 8. So what does that H need to be bonded to? Nitrate. Find nitrate. That's the other half of the compound. And you'll see that nitrate is NO3. Now, look here though. If you look back on some of our earlier examples, H has a subscript sometimes. Like if you look back at hydronitric acid, the last example we did before this one, it's H3N. Whenever you build this compound, you have to check charges. The good news is that hydrogen always has a charge of 1, so you never have to worry about the second part of the compound getting stuff assigned to him. There'll never be Roman numerals, there'll never be parentheses. But this guy has the ability to give H a number. What is nitrate's charge? Yeah, it's -1, so in this case it doesn't matter, they're both 1s. So nitric acid is just HNO3. But do make sure you check the charges. Let's do another. Hydrophosphoric acid. What's the first element that I will write? Always hydrogen right away if it's an acid. We know it must start with H. And then the investigation begins. Look at this word, hydrophosphoric. It either has a hydro at the beginning and an ic at the end, or it has no hydro at the beginning and an ic at the end, or it has OUS at the end. What does this word have? It's got hydro at the beginning and ic at the end. So before it had those things, it just had ide. All right, now that looks like phosphoride, but that was kind of like sulfuric instead of sulfic. It's phosphide. You still would have gotten to the same conclusion. What's the symbol for phosphide? It's just a P. Remember, these guys that end in I are just elements on the periodic table. So phosphide is phosphorus. Check the charges. Hydrogen's always 1, so we don't care so much about him. What is phosphorus's charge? It's a tree. Crisscross the numbers, and you'll get the final formula. The prisoner of Azkaban. Anybody? Anybody see my joke? It's a good joke. Let's do another. Sulfurous acid must have a formula that starts with H because of the word acid. Now we'll take a look at the word sulfurous. As I examine this word, I see that it ends in OUS. So before it ended in OUS, it ended in ite. It looks like sulfurite. What you'll find is sulfite. What is the formula for sulfite? SO3. Check the charges. Hydrogen's always 1. Sulfite on your polyatomic list is a 2. The numbers are different. Sulfurous acid is H2SO3. How are we feeling about this? You try a couple. Write the formulas. Both of them have the word acid, so they must both start with H. Nitrous. Before it was nitrous, it was nitrite. The formula for nitrite on your polyatomic list is NO2. Hydrogen's a 1, nitrite's a 1, so same number, no crisscross. Chromic. Before it was chromic, it was chromate. Chromate has a formula of CrO4 on your polyatomic list. Plus 1 minus 2. That 2 does need to cross over. Anybody get different answers?